Hello everyone. In this video, we will discuss about the questions of trigonometry in which came in your examination JEE Mains 2021. So let's start with the first question. So the first question which came in 24th February shift 1 is find the minimum value of alpha where alpha is equals to 4 upon sin x plus 1 upon 1 minus sin x. Alright. So we have to find minimum value of alpha. So that means minimum value of this particular trigonometric expression. So to find minimum value of this, what we can do is, if I assume this trigonometric function as fx, that is 4 or 1 upon sin x, I can write this as cosec x, and this will be as it is 1 upon 1 minus sin x. So to find its minimum value, we can use the concept of application of derivative. So first I'll find its derivative f dash x. So differentiation of cosec x will be minus cosec x cot x, right? And here we will apply the quotient rules. In the denominator it will become 1 minus sin x square, and in the numerator it will come minus of differentiation of this particular expression, that will be minus of cos x. So we are getting this equals to minus 4 cosec x cot x plus cos x upon 1 minus sin x square. Okay, so we know for finding out minimum value, f dash x should be equals to 0, right? Minimum value will happen at the extreme point. So here if we make it equals to 0, we are getting 4 cosec x cot x equals to cos x upon 1 minus sin x square. Now here if you write cosec again as 1 upon sin and cot as cos upon sin, so it will become 4 cos x upon sin square x equals to cos x upon 1 minus sin x whole square. So cos x and cos x will get cancelled and we'll get the equation as 4 into 1 minus sin x square. So if you open it, it will become 1 plus sin square x minus 2 sin x equals to sin square of x. So we're getting a quadratic in sign over here, that is 3 sin square x minus 8 sin x plus 4 equals to 0. And if you factorize it, we will get the solution as 3 sin x uh, minus 2 into sin x minus 2 equals to 0, right? So we're getting two values of sin x, that is equals to 2 by 3 and 2. So we know sin x cannot be equals to 2 because it always lies in between minus 1 to 1. So we are getting a solution as sin x is equals to 2 by 3. Okay, so if sin x is equals to 2 by 3, you also need to check whether it's a minimum value or maximum. But here, because we are only getting one value, we can say at this particular value you'll get your minimum value. So just put this sin x value over here to get the alpha. That will be 4 upon 2 by 3 plus 1 upon 1 minus 2 by 3. So this will become 2 2s are 4, and this will become 6 plus 1 over 1 by 3, that will be 3 only. So we're getting alpha equals to 6 plus 3, that is 9. Okay, so the correct answer over here will be option number C. All right, now let's move to the next question. So the next question is, let e to the power cos square x plus cos to the power 4x till infinity into log of 2 to the base e. This is equals to p, where p is a root of this particular quadratic equation, and then we need to find the value of this trigonometric expression. Okay, so first let's simplify this thing, that is e to the power. So if you see, this is a gp, right? This is a infinite gp with first term as cos square x, and if you see, common ratio is also cos square x. So sum of infinite gp will be a upon 1 minus r, right? So 1 minus cos square x will be sin square x, and cos square x upon sin square x will become equals to cot square x. So this sum we are getting e to the power, this whole summation, whole series will become cot square x. So p we are getting equals to e to the power cot square x into log of 2 to the base p. Now here I can take this cot square x in the power of log, right? So this will become 2 to the power cot square x, and we know this thing, e to the power log of something, that is nothing but you can say it will be equals to simply 2 to the power cot square x, right? So here we are getting, after simplification, p is equals to 2 to the power cot square x. Now p is a root of this equation. So what are the roots of this equation? It's very easy. It will be x minus 1 into x minus 8 equals to 0. So we're getting values of p can be equals to 1 and 8, and p is 2 cot square x, 2 to the power cot square x, sorry. So it can be either equals to 1 or 8, and we know this, that cot square x will be always, you can greater than 1. So 2 to the power something cannot be equals to 1. So we'll get the solution from 2 to the power cot square x equals to 8. So from here you will get cot square x can be equals to 3, and if cot square x is equals to 3, cot x can be equals to plus minus root 3. But in the question it is given to us that x lies in between 0 to pi by 2, and if it is in between 0 to pi by 2, cot will be positive. So the only solution we will get is cot x equals to root 3. Now if a cot x is equals to root 3, that means x is equals to 30 degrees, right? Or you can say pi by 6. Now we can simply find out the value of this expression, that is 2 sine x. So 2 sine of 30, that will be 1 by 2, divided by again sine 30, that is 1 by 2, plus root 3 into cos 30, that will be root 3. So this 2 and 2 will get cancelled. We will get 1 upon 1 by 2 plus root 3 into root 3, that is 3 by 2. So 1 by 2 plus 3 by 2 will be 4 by 2, that is 2. So the correct answer will be 1 by 2, that is 0.5. So the correct answer of this question will be option number B. Okay. So in this question, first you have to apply concept of sequence, summation of GP, then find roots of quadratic, and then finally your value of cot of x. Okay. Alright. Let's see the next question. Third question is, if x is equals to summation n equals to 0 to infinity cos theta to the power 2n, y is sine theta to the power 2n, summation again n equals to 0 to infinity, and z is this. So we have to find a relation between x, y, and z. This question came in your 25th February shift 1. So now how to solve this? So if you see, this x is nothing but, if you put n equals to 0, first term will be 1, cos to the power 0, that will be 1. Second term will be cos square theta, then cos to the power 4 theta, and so on till infinity. So again, this is, you can see, it's the infinite GP. Okay, and sum of this infinite GP again will be a upon 1 minus r, right? So this is coming equals to 1 upon sine square theta, right? So we can write x is nothing but equals to 1 upon sine square theta. Okay, in the same manner you can find y also, right? Y is equals to 1 plus sine square theta plus sine to the power 4 theta till infinity, right? If you put n equals to 0, you'll get 1. For n equal to 1, sine square theta, sine to the power 4 theta, until infinity. So this is again an infinite GP, right? So what will be sum of this infinite GP? A upon 1 minus r. Common ratio is sine square theta over here. So 1 minus sine square theta is cos square theta. So we are getting y is equal to 1 upon cos square theta. And now what will be z? So z series we are getting equals to, when you put n equals to 0, it will be 1. Then for n equal to 1, it will be sine square theta, cos square theta, and so on till infinity. Again an infinite GP, so its sum will be a upon 1 minus r, right? So from here, now if we need to find the relation between x, y, z, what we can do is, if I cross multiply it, I'll get 1 minus sine square theta into cos square theta is 1 upon z. Now in place of sine square theta, I can put 1 upon x. In place of cos square theta, from here, y is equals to 1 upon cos square theta. So cos square theta will be 1 upon y, and this is equals to 1 upon z. So here if you simplify it, we are getting 1 minus 1 upon xy equals to 1 upon z, and on cross multiplying we are getting xy minus 1, uh, xy minus 1 equals to uh, 1 xy upon z, sorry. This is what we are getting. Now if you cross multiply this z also, we will get xyz minus z equals to xy, or you can say xyz equals to xy plus. Alright, so this is the relation which we are getting which is your option number A. Alright, so this was a very easy question. You have to simply apply the sum of infinite GP, and then you can find easily a relation between X, Y, and Z. Alright, okay, let's see the next question. Alright, so this is your next question based on trigonometric equations. So if theta belongs to 0 to pi, then the values of theta for which sine 2 theta plus tan 2 theta is less than 0. So how to solve this trigonometric inequation over here? So I can write sine of 2 theta as 2 tan theta upon 1 minus tan square theta, applying half angle formula. And similarly tan of 2 theta will be 2 tan theta, sorry, this will be plus, and this will be 1 minus tan square theta. This should be less than 0. So from here, if you take 2 tan theta common, and if you take LCM, it will become 1 minus tan square theta plus 1 plus tan square theta, right? And in the division, both will be multiplied. 1 minus tan square theta into 1 plus tan square theta less than 0. So here tan square gone, 1 plus 1, 2. 2 into 2 tan theta, that will be 4 tan theta upon 1 minus tan square theta into 1 plus tan square theta. This should be less than 0. Now if you see, for any value of theta, this expression will be always positive, na? It can't be less than 0. So that means if this expression, whole expression, is less than 0, it will be due to this expression, that is 4 tan theta upon 1 minus tan square. Okay, so let's simply solve this. Less than equals to 0. Now here again I can write this thing as 2 into 2 tan theta upon 1 minus tan square theta, which is nothing but tan of 2 theta, right? So that means this particular equation is coming out to be simply 2 tan 2 theta less than 0, or which you can say is nothing but tan of 2 theta less than 0. So if tan of 2 theta is less than 0, can we write down the values of theta? Yes. If theta belongs to 0 to 2 pi, 2 theta will belong to 0 to 4 pi, right? And you can see now, if you draw the graph of tan of 2 theta from 0 to 4 pi, it will be something like this, right? Graph of tan of 2 theta I am drawing. Okay guys, so this will be pi, this will be 2 pi, this will be 3 pi, and finally here you will have a value 4 pi, right? This is the graph of tan of 2 theta with, and we want it to be less than 0. So you can see it is less than 0 when 2 theta belongs to pi by 2 to pi union 3 pi by 2 to 2 pi union 5 pi by 2 to 3 pi, right? And last one is from 7 pi by 2 to 4 pi. And this is the interval for 2 theta. So if you want interval for theta, simply divide it with 2. So it will come equals to theta belongs to pi by 4 to pi by 2 union 3 pi by 4 to pi union 5 pi by 4 to 3 pi by 2 union 7 pi by 4 to 4 upon 2, that will be 2 pi. So if you check this interval, pi by 4 to pi by 2, 3 pi by 4 to pi, 5 pi by 4 to 3 pi by 2, and 7 pi by 4 to 2 pi, yes, option number 8 is correct over here. Okay, so a very simple question based on your concept of trigonometric inequation that you can solve using graphical method over here. Clear? So this question was also in the February shift one. So in your February attempt, you got many questions of trigonometry. In this same paper, you can see you got two questions of trigonometry. Okay, let's see the next question. Okay, this is your question from shift 2, 25th February. So the question is, if xyz belongs to 0 to pi and cos x plus cos y minus cos of x plus y is 3 by 2, what will be the value of sin x plus cos y? Okay, sin x plus cos y we have to find, and we have only this one particular equation. So what we'll do, so let's try to simplify this given expression, that is cos x plus cos y minus cos of x plus y equals to 3 by 2. So here if I apply cos of c plus d, that will become equals to 2 cos c plus d by 2 cos c minus d by 2, right? And here in the same manner, because I have cos of x plus y by 2 over here, I can apply double angle formula to write this cos of x plus y as 2 cos square x plus y by 2 minus 1 equals to 3. So now if you solve it, this 2 cos x plus y by 2 I can take common, right? So here it will become cos of x minus y by 2 minus cos of x plus y by 2 from here, and this minus minus 1 will become plus 1, and 3 by 2 minus 1 I can write it as 1 by 2. Okay, now here you can see again I can apply cos c minus cos d, right? So that will be 2 sine c plus d by 2, so that will be x minus y plus x plus y, so that will be 2x by 2, or sorry, 2x by 4, because you have already 2 over here, so that will become 2x by 4, or you can write it as x by 2, and sine of c minus d by 2, right? D minus c by 2, sorry, so that will be x plus y minus x minus y, so that will be 2y upon 4, or you can say y by 2, and this 2 cos x plus y by 2 is as it is, equals to 1. Now, if you take this 2 into 2 in the division over here, we will get final our expression as cos of x plus y by 2 into sin x by 2 into sin y by 2 equals to 1 by 2. Now, by seeing this equation, can you tell me what should be the values of this trigonometric angles, so that it should be equals to 1 by 8? So you can say one of the solution we will get when all of them become equals to 1 by 2, and sine x by 2 will become 1 by 2 when x is equals to 60 degree. Similarly, sine y by 2 will be 1 when y is 60 degree, because y by 2 will become 30 when y is 60, right? That's when it will be 1 by 2, and this will become cos of 60 plus 60, 120 by 2, that is cos 60, that is again 1 by 2. That means yes, these two values of x and y are satisfying this equation. So from here we are getting x equals to 60 degree, y equals to 60 degree. So now what will be sine 60 plus cos 60? So that will be very simply root 3 by 2 plus 1 by 2. So that will be root 3 plus 1 by 2. That is your option number B over here. Okay. So you have to simplify by applying your basic formulas of trigonometry. And last, you have to use this method. Like you can say hit and trial to get the values of x and y. You can't exactly find the values of x and y from over here, because we have only one relation in x and y. Right? Okay. Let's see next one. So this question was very easy. You can say a straightforward question which came in your shift 1 of 26 February. So if 3 sin x plus 4 cos x is equals to k plus 1, then the number of possible integral values of k. So how to do this question? So we know if 3 sin x plus 4 cos x is equals to k plus 1. So we know 3 sin x plus 4 cos x for any value of x lies in between minus under root a square plus b square to plus under root a square plus b square, right? This is the minimum value of a sin x plus b cos x, and this is the maximum value, right? So from here, and this is nothing but k plus 1, so we can say k plus 1 will always lie in between, this will be minus 5 to 5. If you subtract 1 from all the sides, you'll get k lies in between minus 6 to 4. So if you see from minus 6 to 4, how many integers you have? So minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Here we have equality sign, so we will take minus 6 and minus 4 also. So this is 6 plus 5, that is 11. So we will have 11 integral possible values of k over here for this particular trigonometric relation. Okay, so very easy question based on minimum and maximum value of trigonometric function. Right. Let's see the next question. So this question again in shift 1, 26 February. So again two question in the same shift from trigonometry only. So number of solutions of this equation, that is root 3 cos square x is equal to root 3 minus 1 into cos x plus 1. So now if you try to simplify this thing, we will get the root 3 cos square x is equals to root 3 cos x minus cos x plus 1. If you take it on the right hand side, left hand side, and taking root 3 cos x common, I'll get cos x minus 1 as one of the factor. And if I take this also over here, it will become plus cos x minus 1 equals to 0. So yes, here we are getting two factors, that is root 3 cos x plus 1 into cos x minus 1 equals to 0. So that means cos x can be either equals to minus 1 by root 3 or cos x can be equal to 1. Okay, so we need to find number of solution when x belongs to this interval. So we know when x lies in between 0 to pi by 2, my cos x is positive, right? It lies in between 0 to 1, so that means cos x cannot be equal to minus 1 by root 3. So the only solution which I have is when cos x become equals to 1, and that happens at x equals to 0. So basically we have to find number of solutions, so that will be equals to 1. Alright, so you can say in 26 February shift 1 attempt, both the questions were pretty easy, right? 4 lines, you can say in 4 lines we were getting both the answers. Alright, so some of the questions were easy, some were tough, but overall you got good questions of trigonometry and around 6 to 7 questions this year.